Hello everyone, welcome to the 7 Peak Speak. Yeah, please wait.
Um, I need you to open the timer. The timer, yeah, the timer. Full screen. Full screen. And where is the play button?
Hello everyone, welcome to 7 Peak Speaks. Okay, before we start, we would like you to follow and like our Facebook because we normally have this kind of the event and meetup. So if you are interested in the meetup, please follow us so you will receive the news and the blogs and also the meetup that we're gonna have. Normally we have the meetup every month. If you have any topic that you are interested in, please let us know. You can leave the Facebook message to us, so we will working with you, or maybe you can be our guest speaker in the future. We also hiring many positions in our company. We are looking for cloud software architect, .NET developer, front-end developer for the React programming language. We are also looking for full stack developers, iOS, Android, and Node.js and software QA engineering. You can contact us at jobs@7peaksoftware.com or check our website in the gold color that you see on the screen. Or if you have any further question, please feel free to send Facebook message to us. Okay, so after this meetup, we will send a short survey to you. So please kindly provide the feedback to us. So we will gathering all the comments and improve our meetup to the next meetup. Okay, sorry that my voice gone. Okay, so for this page, you can scan the barcode to see what is the newest meetup or what is the newest events of us. We normally have the event in the same Peak software. We do both of the offline and the online meetup. So here, check our upcoming events. Yeah, so today we will talk about MVVM with iOS and SwiftUI. Our first speaker is Hawk.
Today. So I'm Hawk, an iOS developer at 7-bit software. Today I will go you through the basics and overview of animation in SwiftUI. Before you go the more advanced topic with Ton and Andrei for the architect and the best practice for the SwiftUI. So as an overview of animation. So for all of platform or framework, so why do we need an animation in our application? So the animation in any front-end application will give the user the feedback what's happening in the application, and for all the zoom in, the browsing, the scrolling, or the loading indicator, we give the user the feedback of what's happening. So from technical side of view, the loading indicator, for example, will lock user down, and until waiting for something happening in the background, like a API call. So user will understand the application still running, but they have to wait. And a good animation will give the application memorizable. So this concept is true not only for iOS application, but only for all the other front-end application like web application or the Android application or Safari application. So for most of framework, for front-end framework, we have the basic animation property. So it's about the transformation or appearance, like position, a size, an angle, a shape, the color, etc. So SwiftUI itself provides a very simple and robust way to implement the animations. So if you can see some example for transformation like translation, scaling, rotation, or opacity, or background color changing, just using the one line of code to achieve it. Go along with the transformation or appearance timing function, where control for the final state of the object will be rendered on the screen. So we have the several basic timing function like linear or the easy. It means the accelerate at the beginning of the animation, or easy out is decelerating at the end, or easy in out is a combination of the easy in or easy out. We can also have a sprint timing function where it's contained for several factor or parameters like a damping or a velocity or friction. So it will give you combine the parameter will simulate physical movement in real life. So all kind of animation in SwiftUI will be backed by one protocol called animatable. And the next step we will take a look what is the animatable is. So animatable is a protocol from SwiftUI framework, and its companion is the animatable data. And animatable data is vector arithmetic. So what is the vector arithmetic? Vector arithmetic is the extension of additive arithmetic was from the standard Swift standard library. So additive arithmetic will provide you an object conformation object ability to do some primary operator like subtract or adding itself. And at an extension, vector arithmetic will provide the scalar multiplications. It means for any data type or object conform for vector arithmetic will have the ability to scale it up or down itself. So to demonstrate the how the vector arithmetic working, we will take a look into the symbol opacity transition. So we had the two values from and to define the range of the animation. And then the range will be scaled using the vector arithmetic and scale up and down. And finally, we have the final state to display on screen. And from SwiftUI, it will support for many built-in and ready to use the conformation. So for animatable data, we will have a few like listed on the screen, like angle, capsule, or round rectangle, or stroke style, etc. For vector arithmetic, we will have the CG float, double, or float, or animatable pair. So we also have the anti-animatable data. It means it's the nothing. It's a fallback for like any animatable type. It contains nothing. So even we have the many default conformation supported by the framework, but in real life for all the real application, we will have the more complex animation. We need to do the custom. So at the next step, we will go through a symbol assemble to see how the custom animation should work in SwiftUI. So at an assemble, we will animate the number of edge of the star. So here I show the code how to draw a star basically. So you can see that in the screen we have the star conformed a shape. So it of course we have the one factor input called the number of edge. It's the integer number, and because it's a shape, it will have the one function to return a path. And here we have the one function to draw a star path depend on the number of edge. Of course, it's purely trigonometry thing to draw on the context. So here the ensemble of 5H star, 10H, and 100H. And we will implement a custom animation to animate the number of edge of this star. So here we have the we already have the star shape. So we stroke with the color. We define the frame to define the size and location on the screen. And we also have the picker, where we will change the number of edge of the star. And let's see the result. When we change the number of edge from 5 to 10, the star immediately change the number of edge, but no any animations. So why it happened? Because the star it defaultly conform the animatable, but it's empty animatable data, and the framework doesn't know how to display the granular value For example, from 5 to 6 edge of the star. It doesn't know how to display for 5.1, 5.2, 5.3, and so on. So we need to do the framework how to display those values. So we have some small adjustment for our star shape. So first, we need to change the edge to be double or CZ float. Of course, the init function will receive the integer value because the number of edge cannot be a floating number. So we define the animatable data depend on the number of edge. So now it naturally supports the animatable because the double is a conform for vector arithmetic as you know before. And in the drawing path function, we adjust depend on number of edge. For example, the floating value 5.1, we will display actually for the 6, we will round it up. The number of edge, we will display the 6 edge of the star. But the last one will be smaller than usual. So for example, 5.1 edge star, we will display for 5 regular edge, and the last one will be have the size 1/10 of the regular one. So by this way, combined with timing function, it will define the final state of the star. So let's see the update result. So now it animates perfectly. I added another picture of the timing or the duration, the animation duration to have you to see it that animate clearer. So it's a very small demonstration, but from here you can apply the same concept to implement much more complex animations. I have a small quiz. So most of us, we know about the affine transformation. From whatever, because you are the developer, you're familiar with the programming language, or even you are a student, you know it from the high school or from the university. The affine transformation basically is a set of the translation, the scaling, or the rotation, or like a skewing. And SwiftUI is not exception. So it's also support for the affine transform effect. So here the symbol code. I have the my object which using the transform effect with the one button to control the animation. So here's the result. Once I click the button, the object is not animated. So why it doesn't animate? It's because the CZ affine transform, it doesn't conform the animatable. So if you are an iOS developer, you may know CZ affine transform will be animated with the UI kit. How can we resolve it in the SwiftUI? We will go with another protocol called geometry effect. So what is geometry effect? This is another protocol of SwiftUI and conform animatable. And it contains another function to return a projection transform. So projection transform is pretty similar with the CZ affine transform. But CZ affine transform belongs to the core graphics framework, while a projection transform belongs to SwiftUI. And it provides ability to init from the 3D transformation metric. So to resolve our question earlier, so we will create one effect conform for geometry effect, and we conform geometry effect and also animatable. So we will have to define the animatable data. And from our question, we want the object to be animated along with the x directions. So we will define the one value, internal value, dx, with the double value or CG flow value. And naturally, animatable data depend on this value. So the rest, we need to confirm the effect value function return the projection transform. So here simply, we can have the projection transform init via the CG affine transform with the translation value. So we modified our end source. So we had an object P circle, and we modified it with the new effect. And the button is now keeping the same, so it will animate. So next step is the math behind the transformations. Don't be scared about the math. It's quite simple, the matrix. So we have the simple matrix, transformation matrix like a translation, scaling, or rotation. Combine the transformation. So in general, we have the final state of the object on the screen. It's equal with the original state multiplied with the transformation matrix. So because it's a transformation matrix, so we can do like a multiple time. So you can do the multiple time of translation and then scaling and then rotation and then do scaling again and then do translation again. As a consequence, because it's a matrix multiplication, so the concatenation is not commutative. So it means rotation and then scaling will be different scaling and then rotation. Or translation and then rotation will be different rotation and then translation. So here the example. If you can see the translation then scaling, we give the final state different from the scaling and then translation. Or some lucky way, you will have the translation and then rotation with the final state completely the same with rotation and then translation. But the way it goes from the beginning to the end is completely different. So as the last step, I will introduce you another protocol. I believe it's the most flexible way to implement the custom animation in SwiftUI. It's called animatable modifier. So what is the protocol is? The protocol is a combination of the animatable and the view modifier. So the protocol animatable, you already know it in the very first of these presentations. So the second thing is the view modifier. The view modifier is another protocol of SwiftUI. It will receive an input of a view and modify it and return another view. So by combine two terms of protocol, we have the protocol composition, and we can apply for any kind of view as long as can be displayed on the screen. Again, we will go to another simple example to see how it works with the animatable modifier. Here I will define the one a progress indicator. Of course, it's a modifier. And I define two types of animation, one for circular and another for sliding. So here is an example of some state in the end. So if we have the value of the 20%, we will display the part of like a full circle, and for the similar thing for sliding. So I create one modifier called percentage modifier. It conform for the animatable modifier. Because it conform animatable modifier, so I have two part, one animatable and another part the view modifier. Because it progressive, so naturally I will have the percentage at an input, and I divide it by the double number. And the double number, because it's conformed for vector arithmetic like we know earlier, so it's now become animatable data. We have the get and set function to control it. And in the body, depend on the style, I will have the two type of circular and sliding. And the private function will provide two steps. And the sub is again, it's just purely a trigonometry thing, and the row in the sub depend on the percentage. So I will hide it here. Nothing special. And in the end, it will be a V modifier for the structure. So we get a content at an input using the sub depend on style, and we clip it. So with this way, we can modify for any kind of input as long as it's a view in SwiftUI. It can be an image, it can be a text, it can be a color, it can be the shape, or whatever, or your custom view, of course. So let's take a look into the result. So first, we have the shape, a circle shape, using the circular animation. We have the image, we have a text, we have a another rectangle. But rectangle we can answer combination with in the combination with the border, and answer another modifier called rotation effect, and it works perfectly. So at a conclusion, what is the effective way to implement animation in SwiftUI? So from my point of view, first, we need to use as much as possible what we have in SwiftUI is ready to use or to be in functional. So for example, if you want to do the frame modifier, we can use in the frame modifier, or we can use in the translation, the viewing translation, or we can even using the 3D rotation. Think about it first. And if you really want to modify for every element of the transformation metric, because you know about it, right? So the x, dy, or scale x, scale y, or the skewing, or you want to do some special effect based on the transformation metric, think about geometry effect. And lastly, if you want to implement for a custom animation can be applied for any kind of view, or at least a set of view, or set of object type, think about animatable modifier. So we can find the shortcut of the presentation in the GitHub link. Of course, the last step should be the Q&A if you have any question. Then, thank you for listening. And next step, welcome, Tan.
Okay. Hello, my name is Don. Today, we're trying to build something great, something that matters. We're gonna create app with MVVM in the SwiftUI. We're gonna update view by using state. For example, when we edit something on text field, and we also want it to display on a label, we're gonna pass data between view by using binding. We have, for example, we have two child views and pass data between them. We're gonna update our list view, and we're gonna share data in our app by using environment object. So why SwiftUI? Because SwiftUI is a feature. Currently, there are many apps require iOS 11 and later version. In addition, Instagram and Twitter require iOS 12 and later. In my opinion, next year or in the next 2 years, it will be SwiftUI time. Here's the topic today. I'm gonna talk about property wrapper first. We're gonna create a property wrapper, then property wrapper in SwiftUI, and MVVM in SwiftUI. Why should we know about property wrapper first? Because there are many property wrapper in SwiftUI that Apple provides us, and we often use it. So what property wrapper UI is? Property wrapper were introduced in SwiftUI in Swift 5.1. This is tool provided by Apple language and is one of Swift language feature. And a property wrapper adds a layer of separation between code that manage how a property is stored and code that define a property. Basically, we want to share data to user default. What we do in the normal way, it takes 4 lines of code. As you can see, var, app language, string, set, get. And on the other hand, if we do in a property wrapper way, it's just 1 line of code. And how to create a property wrapper. There are 2 things we need to provide when we create it. First, we need to define property wrapper keyword on the top. And second, property wrapper must be property name value. In this code, we just make it a generic type to be whatever you want. And we have default value to be sure it will not be nil. And one more example, we're going to use project value. You might use it before from state. It has project value as well. We can access project value by using $sign as a prefix. So what project value is? Same as its name, project value is projecting a value from property value. Project value allows us to project another value by put $sign as prefix. It enables us to add logic in a way that doesn't impact our code side at all. So we're gonna create a property wrapper to use project value with the condition like this. Phone number should have 10 characters. And we can check it is true or false by access the project value. Here is the code. As you can see, the project value at the set, we can set the condition and set the value to the project value, and we can access it. It will be different type from the web value. Yeah. And how to use it? It's easy. You can access the property wrapper by assign as a prefix, like this. So next is a state. What state is? State is one of property wrapper that Apple provides us. When the state value change, property name body inside our view will be called again. That means we should use state only inside view and set it to be private. Look at it example. First, we define state name counter, and when we place a button, we want to update the counter, and we want to re-render a text. That's it. It's simple. And in the SwiftUI, we have view lifecycle as well. For the Swift, you might know will did load, will appear, something like that. But in the SwiftUI, we have 3 pages: appearing, updating, disappearing. Start with appearing. When the view start, it will do initializer, and then subscribe to a state, to a body, and render view inside the body, such as text, button, and then do on appear for the text and button inside the body. Next, updating. It will not do initializer and not do subscribe to state. It will do body and re-render view again, and that's it. Lastly, the disappearing. It will not do anything. It will do on disappear. That's it. The project value. For the state, it has project value, and the type is binding. So what is binding? Binding property wrapper let us declare value that come from elsewhere. Binding work with the state. For example, our view has child view. When we update something on child view, we also want it to update on the parent's view as well. Let's take a look at this example. In this example, we have a child view called custom view. When we hit a button, we need to update a random number, and we need the parent to update as well. We can use binding and state, something like that. For publisher, publish allow us to create observable object that automatically notify to observe object or environment object. Here's an example. we create properties with the observable object protocol. It is simple. Something, for example, I am a YouTuber and I have a channel, and if I have a new video release and nobody subscribe me, and it will notify no one. Observe object is something like subscriber. If you subscribe to some YouTube channel, you will get notified when the new video release. Here's an example code. And use this together. When the publish, first it will subscribe to the publish, and then when the publish value change, it will update the body. Next, environment object. Environment object property allow us to create views that can share data. If you create a user that will be shared across many parts of your app, for example, app setting or user setting, it's great to use environment object. Here's an example. We create user setting class with observable object protocol to use publish, and we create an instance in app flow level. Use environment object to pass environment object to elsewhere. And when we want to get or edit user setting, we just define an environment object in the view that you want. And what is different between environment object and observe object? Both can share across many views. Both can update any view. But environment object, but if you have 4 views, you want to pass data from view 1 to view 4, you can use environment object. You can define environment object for the view 1 and you can use it for the view 4. But if you use observe object, you need to define it every view. You need to define observe object to view 1, view 2, view 3, view 4. That is the difference. So let's create a project with MVVM. Here is the project. What I did, start with the environment object. Here I create a user setting by using publish and observable object. And I create an instance here and pass it to elsewhere by using the environment object. And second, I will show it on the setting views here, user setting. MVVM project, setting view, show something like that. Here, hello tone. And we're gonna talk about state. State can use to present by using with binding. Here, login. So if we click on the login, it will show the login views. And when we click back, we just make it's presented to be false. It will be back to the first screen. And for this view, on the init, I create a view model instance here with the observed object to subscribe to the publish. Here, the view model. On the init, I do some requests, and after finish, I map response to our model, and I do data binding here to make sure it will be optional. After finish, the publish will tell the observed object, oh, there's some update. Please update your body. It will update the body again and do the list again. It will show like this. And it is a simple way. There are some issues about performance and memory management. Don't worry, Andrei gonna tell us. Thank you. Fuck. No Q&A.
You can face some issues that can cost you time to change it. We use this SwiftUI in one project in production, and we face many challenges that we try to solve it in different ways. wouldn't tell yet that there is some really go-to way to start your application. But I will tell you the way we kind of could achieve it. I want to talk about 3 topics mostly. It's about published object will change and observable object in general. Then about navigation link, as we use it a lot. And how to create observed object with parameters. Somehow Apple documentation is missing this part, and that brings a lot of questions when you start to implement it in your way. So first, about observable object in general. Observable object is an object that sends the object will change stream, and your view will get updated. I'll show you example code. When we work with an observable object, we can use state object or observed object. The difference is that the state object managed by SwiftUI, it creates when SwiftUI present the view and it cached, so you don't need to worry about memory management. It works in this way. Oh, sorry. When your observable object change any property that marked as a published, what it does, it send the object will change. So in this example, you can see it starts simple timer every second, and it doesn't have any published. So it's just normal property, and whenever you change it and send, the view get updated. So you can see this counter. When we use published, it works exactly the same way. So I just don't need to set this line about will change. Instead, I just mark it as a publish, and it works exactly the same way. When we work with observed object, in this example, you can see it also works the same way because it's just simple view. We just set it as an observed object. So every time when this view created by the parent, this object will be recreated. I will show you later in more details. And in this case, I just want to show you that if you mark any of your property as a published, SwiftUI behind the scene send object will change, and your view will get updated even if you don't use any property. So in this example, you can see that I just defined state object and I don't use anything there. And when I come here, you can see that it creates child view, and child view creates its own view model every second, because this object updates every single second, and this body called every single second. So that would be the first issue that you can face when you start to work on your own architecture. That's mean to make your application performant and avoid memory leaks or any memory issues, you have to be sure that your body is very lightweight. So if you want to do any calculations that takes any time, be aware that it can triggers many times behind the scenes. Even if view not presented on the screen, it still will get called. Another issue, if you work in this way with the observed object, you can see that this init property will also get called every time you create your view. That means your init should be as lightweight as possible if you decide to go this way. I will show some workaround what we found about this, but before we moved on, I want to talk about navigation link, because navigation link that's what you're gonna use, and that can bring you the same issues. The first issue that when you create navigation link, you have to specify the destination, and this destination is another view. That means when this body will get called, every of these destination views will be created. If inside any of this view you create your own view model object, it will get created on this tab. To show that, so again, when I click, this body get called, and we can see that each of these view models creates inside. So this is child 1, child 2, child 3, and each of them create child view. And this child view creates view model. And you can see that when this body get called, all 3 child view creates, and it recreates view model. So first way what you can do, like you can do 2 things. First, you can do something about your view model by caching it or do whatever you want. Or you can create lazy view to create this view only when you need it. Like in this example, we click lazy view, nothing happens. We go to child 1, then we create child view. We go child 2, we create child 2. It's done by simple creating, instead of child view, we create lazy view. So we just create a wrapper, just simple wrapper, simple as it. You just provide the closure to build your project, and when SwiftUI renders it, it actually creates that view at that time, and view model will get created at that point. It could be a little bit maybe annoying or error prone to write this way. So another solution would be just create another wrapper for lazy navigation link. So what we use, just instead of using the normal one, we just use own created one, and you can see if I go to navigation link, it works in this way. Again, if I use the default one, all child view will get created at that point. Yeah, all of them created. Another challenge we faced when we want to manage the routing, let's call it deep navigation. Let's say we have multiple steps in our application, like maybe it's a registration when we have email on one screen, password on another screen, whatever else screen, and in the end we need to finish that the whole flow and come back. If we want to do something like this, so we create one view, and this deep navigation child view has one binding property, and this is on next. And the view is simple. We just show the title and show the button with the next. When we click next, we just change the binding property to true. And what we want to do, so we create this view, we pass property to show the next. So when I click this next, we change it to true. And when we change it to true, we want to activate this navigation link. And same on the next screen, when I click next, I pass on next go to 3, and I activate it on 3. So it's like we want to have one view that manages the all roads. It looks pretty okay, but when I click next on the second screen, something's going on like that. The problem is that navigation link of one view, or one particular view, change that value back to false every time that link gets disappeared, right? So as soon as we click next, we change this property. When we go next, something broken inside. So how we can fix? In a simple way, we just create all our views and manage it inside. So on the first screen, we create nested view 1, and this is just a wrapper to show our view and navigation link to the next one, to the next two. Next two has the same state property to show the next, and it goes until the end. And when we reach the last screen, 1, 2, when we change this property, we just show the full screen alert, whatever it is. And when we click close, we show next true, show next to false, and we close it back. That could be a little bit too much code if you have many cases in your application when you have this flow. It could be registration, it could be sign in, it could be some profile flow, whatever, in many steps. And then you would need to duplicate your code, and if you have a view models inside and so on, it will be really mess. To fix that, we've created kind of router navigation view that replicates this one and cascade the create this body. So you provide the closures of your view builders, like on this example. So this is I show my first screen, the second one, and this is third one. Also know that these properties we use on each screen, we actually doesn't need it. We just pass it to the view to change the state, and then we use it as a is active to navigate to the next screen. We move this property as a presented inside our router navigation view. And you can see in the body, it creates our first view, and if it has more closures to build next to you, it just create itself and take the builders without the first one. Maybe a little bit looks complicated, but if you take a closure to the code, by the way, the link to this repo with all examples would be available online, so you can check it any times. So how it works? We create our navigation view, router navigation view, and it provides our that presented property that we pass it to our view that we want to change the property to the next, our custom router. So that's the first screen of our router navigation view. As soon as we click next, it changes this property, and this property sends to the next closure. So that is our child 2 view, and when we click next, it will change this property to show this closure. When we present this screen, this is our last step, so we don't actually use next over here because it will lead us to nowhere. Instead, we have our property, some different properties that you would like to change. And in this case, we use it to present our model. That's how it works exactly on example before. And we still can use one view as a router and keep less code than here. So that is a second case that we faced. Another thing that till now it's not really easy to go to back. As you see here, when I go all the way back and I want to come back after this to the beginning, it's not really possible because navigation link doesn't work well all the time. So the workaround for this for us was just presented the whole flow in a model screen, and when we finish it, we just close the whole flow exactly like we do it here. The last thing that I want to talk is how to create observable object with the parameters and what issue you can find there. First thing, you need to think about caching your object, because as we notice, if you use state object, the SwiftUI manage it for you. The problem is that you cannot access state object from the init. That means you cannot pass any parameters from the init. If you would like to use state object, one of example, you have to do something like that. You create your view with some parameters. We would like to, we cannot create the state object over here because we created in this point. And it created when the body get execute, not when init executes. So we cannot pass it directly to the model like that. If you try to do that, you would see something like that. So in this workaround, you can use onAppear and pass it. But this has different drawbacks. First, you have to use some parameters like that just to pass it to your view model. If you have many parameters, you have to duplicate all of them. Second, you use this one, so you put your logic inside the body and you put it on Appear here. And the third, more serious problem. that your properties of your state object should be optional. As we can see here, our ID is optional. It will really change your architecture and the way you work. Like in this example, I'm just trying to fetch some data, whatever, from API, from database, or whatever. When we set the ID, right? You can refactor this code to look a bit better, but the idea would be the same. You have to wait when ID change to set up your project, set up your object. Also, you have to have the default state when it's nil for all properties. And it doesn't look like really much readable and maintainable. If you would like to use observed object, your observable object doesn't have optional anymore. But you have to create it in an init. That brings us to the previous issue when you use navigation link or create it in a list or whatever. All your view models will get created every time SwiftUI calculates your changes in your view, called the body. And if we run this example, so first, what's going on here? We create our view model when we show this view, and in this body, we create another object and pass the ID. It's the example from the real life project. Every time you have a nested views and you want to pass some parameters there like ID or whatever, you have to do something like that. That means when this object will be recreated by the parent, it will create this view model. And then when something changes inside this object, when this view model updates, view will call this body. When this body gets called, every time it updates this not cached detail view. This not cached detail view is kind of simple. It has a view model. It just exactly replicates the parent view. It has its own view model that we get parameter from outside. We have some details that we try to fetch it as soon as we create it. And on this view, we have a text field. And this text field changes the title. And title is published. That means every time we change something in this title, this published will notify our view to update the body. And when the body updates, it creates this not cached detail view. And this not cached detail view creates this view model. So you can see, if I open the log, so you can see first it was empty, then after 1 second we load the title, and same happens in the detail view. In 1 second we load details. So it gives us another issue. As soon as I type this, you can see the detail disappeared because this view gets recreated, and this view model has default value. So this view will show default value, and after 1 second it will show our details. And you can see every time I type something, the non-cached detail view model get recreated. To solve this problem, you can go and try to cache your previous value somehow to don't have details. That means instead of using this, you need to cache somewhere this value and get it like self details from cache. Or you have to cache your whole view model to not get recreated every time. We went with the second approach to cache the whole view model. To do that, we create something called view model provider, and it has static cache over with weak objects. That means we don't store the reference in this cache. Whenever SwiftUI creates a view and view creates a view model, it stores the reference in the memory. And as soon as it gets deallocated, our cache has a nil. So we kind of safe to go there, and we can be assured that we don't introduce any memory leaks over here. How we use? We have this cached function that accepts ID. ID in our case is just a string, so it's your some kind of identifier for caching. In case you have a, let's say, table view with 100 different child views, and it probably has different IDs, but it's the same view and the same view model. So you want to save different view model with different IDs or different link somewhere. So what we do here, we just create the key depending on the ID and just the type of the given object. And we check if the cache has non-nil value. And if it has, we just map it. And if it doesn't, we have another property, parameter with a builder closure that get called and cached. So if we want to use it, we just take this code and turn it to this. Instead of creating view model directly, we ask our view model provider to check if it has this view model of this type for this ID. And if it doesn't have, this body get called. We can test it here. As soon as we type something, nothing change. But if we go to our provider and turn on the output, we will see that every time we type, you see use cached object. In the previous example, without provider, it just recreate object every time. So, when you work on your own architecture on SwiftUI, you can't really take your knowledge of the UI kit architecture and use it in your project. Be aware of all these issues and try to build architecture with all of this information take into account. So as I said already, you can go through all these examples and you can see this lazy view, lazy navigation link, and the view model provider and just use in your project, or find another way to build your architecture. In the project we're working now, we still trying to find the best way to implement MVVM or whatever architecture we can call in the SwiftUI, but it seems that it's easy to create the views with SwiftUI, much easier than in UIKit, but it gives a lot of pain when you're working on the data model, and unless you're aware of all of this stuff that SwiftUI do behind the scenes. That's it from my part, and if there's any question, do we have a question?
Hello, yeah, we just have one question, but I think you already answered it. Let me find it here. Do published and observed object always goes together?
We can go back to the first example. Yeah, as you can see, again, I will close the simulator. If we use observable object, we don't really need to use published, because published, what it does for you is just call this one. So if you don't use published, you are responsible for calling this one line of code every time you want to update your view, and that's it. And also, as I mentioned before, be aware that if you use published, and even if you don't use any property, it will get updated, because the view check the changes of the whole project in object in general. It doesn't matter which exactly property you have changed. So that's another thing that you really have to worry about. Any other question? No. Okay, if anytime you would have a question, you can comment in GitHub to this project or on Facebook. And thanks everybody for the attention.